Hey, what's up, guys? So, starting chapter 8, so what are called Markov chains. It's not nearly as complicated as it looks. So, if you take a look, you can read that stuff there to yourself. Basically, long story short, you've got it's kind of probability stuff. It's just stochastic processes with tree diagrams. So, if you look at number 1 there, each stage result is one of a fixed number of states, and then the second one, conditional probability of a transition from any given state to any other state only depends on the two states. So in other words, it doesn't matter what else has happened like 2 times before. So the probability of the next thing happening only depends on what happened right before it. So if we move this over, if I can figure out how to do that. There we go. All right, so we've got a situation here. Says, say we have a person that is either employed or unemployed on a week-by-week basis. So we've got some information at the top there. It says if the person's employed this week, the person will be employed next week with probability of 0.7 and unemployed with probability of 0.3. Okay, if they're unemployed this week, the person will be employed next week with probability 0.6 and unemployed with 0.4. Says this is an example of a problem that can be solved using a Markov chain. There are only 2 states, E for employed and U for unemployed, and they only depend on each other. In addition, the next state only depends on the previous state and not anything else in the past. In other words, next week only depended on this current week. So, number 1 there, if the person is employed now, what's the probability the person will be employed 2 weeks from now? So, easy way to do this is we can make a tree diagram. So, we're starting off, they're employed, okay? And then they've got 2 options for next week. So this is, I don't know if I'm going to be able to write this very well. We'll give it a whirl. 1 week away. So they're either employed or they're unemployed. Okay, employed. So if they started employed, so over here, this is now. If they started employed, next week they're employed with probability of 0.7. So 0.7. Unemployed with probability 0.3. Okay, so then the next week, so this next part of the tree would be 2 weeks. Sorry for my bad handwriting on my iPad here. So the next week, if we're right here on employed, then again, they're either employed or unemployed. Employed, if they were employed right now, in other words, the one I have circled here, they're still 0.7 for being employed again, 0.3 unemployed. Okay. Our other thing that can happen, so after 1 week, they could be unemployed. After that, they either go to employed or unemployed. All right, but now we're using this other information. It says if they're employed this week, they're employed next week with probability 0.6. So there's 0.6, unemployed, 0.4. Okay, so if I want to know probability that they're employed 2 weeks from now, it's that spot and that spot, so we just multiply 0.7 times 0.7 would be 0.49. And then down at the bottom, 0.3 times 0.6 would be 0.18. Add them together. Try not to mess this up. Okay, add them together. 0.49 plus 0.18 would be 0.67. So 0.67 chance if they're starting out employed right now, 2 weeks from now, that they're employed again. Okay, number 2, if the person is unemployed now, what's the probability that the person will be unemployed 2 weeks from now? So now our tree starts with unemployed. Okay, so they could either be employed or unemployed, but if they started unemployed, now it's 0.6 and 0.4, and this is 1 week from now. Okay, and then after that, same deal as before. They're either employed or unemployed, and this would be 2 weeks. So if they're at this stage employed, that means they have 0.7 and 0.3. If they're at the bottom unemployed, they're 0.6, 0.4. Okay? If I want the probability of unemployed 2 weeks from now, So either there or there, those two outcomes. 0.6 times 0.3 is 0.18. 0.4 times 0.4, 0.16. Add them together, 0.34. Okay, so that's kind of the basics of this, but we're going to kind of add a little bit to it. So if we take a look at the next slide, if I can get to it here, bear with me, without trying and ruining this whole work that I did. Okay, we're back. All right, so if we take a look at this now, so this worked for 2 weeks from now. All right, problem is these things in the real world end up being like 10 weeks, 20 weeks, 50 weeks, things like that. So instead of using tree diagrams, what we use are called, we do transition diagrams. Okay, and we also use what are called transition matrices. All right, so transition diagram, these are very easy. So if I wanted to set this up, okay, and draw what's called a transition diagram, okay, I have my two states that we can be in. We can be employed or unemployed. All right, all we do is we just draw little arrows with the probabilities for what can happen. So if we start with employed, all right, the probability of being employed again is 0.7, so we just draw like a little arrow going back to itself. That's the probability of 0.7. Probability of going from employed to unemployed, 0.3. Okay, so that's going from employed to the other options, either back to employed again or unemployed. Okay, the other thing, if we start as unemployed, we can stay unemployed, which I believe that was 0.4, or we can go to employed, which was 0.6. That's a transition diagram. Okay, you just draw your states, draw your arrows either back to itself or to the other state, what the probabilities are. All right, there will be times when you might have 3 states. Sometimes one won't go to the other. That's okay. Okay, sometimes it's 100% chance of going to the other and not going to itself. So it's kind of reading it carefully, drawing the arrows for the probabilities. Okay, transition matrix now, all right, shows this same information, but in matrix form. Okay, so I'm just going to draw a little E and U, E and U. Okay, so the left side of the matrix, right, that's like our first observation. So like in the last example when he said we started as employed or we started as unemployed, that's what the left side of the matrix is. So I'm just going to write first observation, if I can write all that. Okay, that's his observation, sorry. All right, the columns represent basically our second observation. So second observation, or it's also sometimes called basically after one transition. Okay, so the second observation or after one transition, that means the same thing. Okay, so over on the left side, we started our first observation. If our first observation was employed, we can be employed again with probability 0.7, or unemployed, probability 0.3. Okay, or if our first observation is unemployed, we can become employed as 0.6, unemployed 0.4. That's a transition matrix. Notice the rows add to 1, okay, because if I started as employed, I have a 100% chance of doing something, all right, or same thing if I start unemployed, I have a 100% chance of doing something there. Okay, so that's drawing the transition diagram and the transition matrix. So I'm going to try to get us to the next slide here. Okay, so down here is just kind of some basics. You might like screenshot this. This kind of can help you when you're setting up your transition matrix, if we look at the example of the matrix up here at the top, okay, and then explaining what happens each time, so kind of what these parts of our matrix mean. So like the 0.3, if we look down here, maybe do that, what that is. Okay, so it's like the probability of something that is currently in state 1 and remaining in state 1 is, on the next stage, is 0.3. So you can see there's the 0.3 up there. Okay, and you can look at all the rest of those. So this is a good reference page to know. So like I said, you might screenshot this, would be a good idea. Okay, so other thing, if we have a transition diagram, here's a couple examples of those, and I'm going to draw the transition matrix to represent the diagram. So for this one at the top, okay, I've got my two states. All right, if we look over at state 1, it has a little arrow going back to itself, probability of 0.2, so that means, okay, remember the first observation, or where we're at right now, is the rows. So if I'm starting on 1, going to 1, that's probability of 0.2. Okay, if we look from 1, if we take a look at the diagram, there's no arrows here, but going to 2 can't be 0.3 because that wouldn't add to 1. Going from 1 to 2 has to be this 0.8, so this arrow has to go like that. So 1 to 2 is 0.8. If we look at going at 2, so if I'm starting at 2, 2 back to 1 is 0.3, so 2 to 1 is 0.3. 2 staying at 2, 0.7. There's my transition matrix. Okay. Do one more here. If I have 3 states, so 1, 2, 3, 1, 2, 3. Okay, these will always be square matrices. So if we take a look now, okay, on 1, so 1 doesn't go back to itself. There's no little circle going back. There's nothing like this going back, okay? So 1 can't go to itself, so that tells us 1 to 1 is 0. Okay, and then that means, so 1 to 2 and 1 to 3 have to add to 1, so that tells us, okay, the arrows will show up in your book, so don't worry too much about that. So 1 to 2 is 0.4. Okay, the arrows just didn't show up on this slide program. Anyway, so 1 to 2 was 0.4, 1 to 3, 0.6. There's my first row of my transition matrix. Okay, and then we go to 2. So 2 to 1, it's going to have to be that 0.5. 2 back to itself, 0.2. 2 to 3 then it has to be 0.3. Again, your rows always need to add to 1. So that's that arrow. Okay, now if we look, 3 going back to itself, so 3 to 3 is 1, that means the rest of these are just zeros. So if I'm on state 3, I can't go to anything else but stay on state 3. Okay, so that's going transition diagram to the matrix. All right. I believe that's, yeah. So last thing now, example going from the other way now. So the the matrix to the diagram. So it always helps me, I always just write the states there, even though it's obvious, but it is to help draw it. So I've got state 1, state 2. So 1 to 1, that's 0.4, so the little arrow going back is 0.4. Okay, 1 to 2, we can see 1 to 2, right there is the 0.6. Okay, 2 to 1 would be that 0.3. and then 2 back to itself, 0.7. There we go. Okay, down below, 3 states. So I usually just draw it like this. Okay, so 1 to 1, 0.1. 1 doesn't go to 2 because 1 to 2 is 0. Okay, so we don't have an arrow going from 1 to 2, but we have one going from 1 to 3. That's 0.9. Okay, if we go to state 2, 2 doesn't go to 1 because that's 0. Then we have 2 back to 2 is 1, so that's the only thing that can happen. If I'm on state 2, has to stay at state 2, and it just always stays at state 2, no matter how many transitions we do. Okay, state 3 goes to state 1 at a probability of 0.3. Okay, 3 goes to 2, probability of 0.2. And back to itself, probability 0.5. And there's our diagram. Okay, so hope this helps. I think we'll probably have a Google Hangouts meeting or something where you guys can ask me some questions live on Wednesday morning. I'll have that posted. Hopefully we can get a time where a bunch of people can get on there. But make sure to ask questions. Check out the Finite Show if you're still confused after this and you're having trouble with any of the homework. And obviously ask me some questions. So hope you guys are doing all right. I will hopefully see you guys at some point. Have a good day.